Hello and good morning. We have a full week with a lot of program ahead of us. I'm Dr. Freeland Wild. I'm heading our performance augmentation lab here in Brooks, and I will be introducing you to what augmented reality means. And subsequently, we will have a lot more lectures. I also welcome the people who are listening to us from externally through our Facebook live stream. I'll start a little bit with the motivation of what this is all about. And that is actually, I think, a philosophical question. Truth is reality. That's an old quote from Thomas Aquinas. Probably he stole that from some other scholars who stole that from Aristotle. And in his works, you find quite often in the essays about truth, the saying that to say of what is, that is true. And that is an interesting notion, that reality is something that is true, that is objective. So that means for centuries, if not millennia, scientists like myself have been pondering about this idea and have been thinking about how to establish unity between the thing in itself and how we perceive it and how we talk about it. And that is a quest for representations. I've added my own good share to the quest for representations. This is one of my books about learning analytics in R, a quest for mathematical representations that make texts understandable in a geometric way. And that is one example of many of these representations that allow us then to forage for information, that allow us to support decision-making with analytics, as you see here, that allow us to even generate feedback automatically. In that book, I've been using it to grade essays automatically. And it allows us to create personalized learning environments and many, many, many other applications. So representations are an important piece, but maybe we ask ourselves the wrong question. What instead of trying to represent reality, we could actually make reality. And what are the rules of the spiel then, if we treat reality as a medium that we can manipulate? The key to unlock this new medium is certainly found in perception. And perception, if we untangle that a little bit, is an active process in which we reconstruct what we perceive out there. We reconstruct reality from the stimulus offers that we get. For example, we already pre-process on the retina. That happens naturally through the wiring of the photoreceptors. So some of the basic feature distinguishing already happens at the back of our eye before it even reaches our brain, really. Then at the back of the head, we have the primary visual cortex, which then is responsible for detecting shapes, seeing detail, color blobs, detecting angles. We have a specific sensitivity for certain angles, for example. And from there, then it crosses the whole brain. There's a what stream and a where stream that is responsible then for seeing the world and detecting the world as we know it, for detecting reality. Yeah, so it's an active process. That's here one of my most favorite optical illusions as an example for this active process. I hope you slowly start seeing it. Those of you who already have seen that illusion, please don't blurt it out. Interestingly, the way it works with active is that it works in two directions. So it works from the stimulus offers to the brain and from the brain and also down. So once you know the optical illusion, you're unable to unsee that there is actually a cigar poking out of the wall. And our visual memory, as we know from experimentation, is immensely powerful. To get any recognition error rates that are significant, you have to show test participants about 10,000 pictures to get a few percentages of errors in whether they have seen the pictures before or not. If you show them just a couple hundred pictures, they will have every single one of them right. And that even weeks after. So that's experiments from the 1980s about the picture superiority effect. Yeah, so it is an active process, and we reconstruct reality. So let's take that a little bit further. If we reconstruct reality, then at the same time, this perception process is responsible for building up our experience, for building up our memories, and these then again shape the way we perceive the world. Then that is a mutually influential process. We have an episodic memory, a sensory semantic memory, a muscle memory, and many others. And if we want to hack into this, we can hack into this process by using gateway devices, and that way we can manipulate then our perception and ultimately then our experience. And the other way around, if we use our imagination and fantasy, we can manipulate in a downwards way. That is quite nice to distinguish as well, that we have reality, virtuality, and fantasy that influence the way we see the world. And especially in that overlap here between virtuality and reality, we have augmented reality, or sometimes also called mixed reality. When we kind of dive completely into the virtual part, then we have virtual reality. I'm mentioning fantasy especially because it often helps us to bridge over where technology fails. So we can use illusions to make things work where technology is just not good enough as such, or not yet good enough. And that's a useful thing to know. I also mention it because for storytelling, and we will have a dedicated lecture about it, it's an important thing to realize the way we construct reality from kind of more feature-oriented things to the perception of objects, groups, or worlds. It happens almost magically with a principle called supervenience. One level of reality supervenes the other, and we don't quite often know how that actually happens. But it certainly is something that is deeply rooted in our fantasy, in our world of imagination. So when we look at the overlap between reality and virtuality, when we look in between those two, what are the devices that we can use to manipulate the perception? We have a quite big array of possible devices that we listed here. From how close they are to the eye to how close they are to the object, the blue blob. We have devices like spatial see-through displays. I'm sure you have held them in your hands, the iPad applications, which you point at the Coca-Cola bottle and then there's something funny happening and some music playing. You may have seen in a museum spatially aligned projectors that are set up in a way that they project nicely onto the room or onto specific objects as well. In recent times, it's quite popular to have non-stationary projectors that you can either hold in your hands as well for augmented reality discovery, and there's some really nice museum applications that you point at statues and suddenly the statue comes alive and that sort of stuff. Or which you may have seen at a music festival, some light installations where you have projectors that are moving, or where you have spatially aligned projectors. When you hold it in your hand, we have the handheld display. When it's fixed installed, like at bus stops, we have the spatial see-through display. The ones that we will look at for development here are up here. We will look in particular at head-mounted displays where you have a pair of smart glasses that have stereoscopic displays and allow you to create that illusion in the perception of the space as you need it. There's also the other way around, head-mounted projectors that you wear a helmet that then highlights what you need to do. projecting onto the environment, and there's something that is very experimental, and if you ever want to see some horrible videos, go and Google for contact lenses with built-in AR. And there are even some do-it-yourself tutorials. I advise strongly not to do that. I wear contact lenses myself, and the pictures I've seen there, I'm sure that's definitely not healthy. But it is possible to bake in your home environment 2 contact lenses on top of each other and put a 4x4 pixel display inside. That's what you wouldn't do, but there are, of course, other possibilities that are currently investigated by commercial companies. There are prototypes and patents that are had for retinal displays, where you have contact lenses with a built-in display, or a solution where you have kind of mirror foil on the contact lens and you're projecting onto that mirror foil with a projector that is close to your eye. Yeah, so with head-mounted displays, or smart glasses as they're also known, we can build examples like this one here, for example. That is on a BT200, which came out a couple of years ago. There was a Halloween joke that we built there. We were only using the video see-through, as the latency of the camera and the IMUs was not very good at that point in time. And to project it kind of ghost-like into the real space as you will during this course, it wasn't possible then back in 2014, or not with the hardware that we had. Yeah, but it creates nice illusions that work quite well, and people react to it. So at that point in time already, many people around the globe had experimental things up and running that work and that create quite nice illusions. Yeah, what do you see here again is basically what I see in the glasses in that little inset video. And the way we built the interaction with the ghost when it turns red and jumps at you, it's range-based. We built a small method that calculates how far away you are from the poster we used as a projection frame in the background, as a marker frame in the background, and then the ghost would lash out at you. And if you very much believe in ghosts and walk through it, you feel a shiver running down your spine. It would work surprisingly well in a rather dark room and with probably some other visuals. At least I heard rumors that one of the big companies for smart glasses were experimenting with a room of horrors, and the people who had seen it, some of them refused to ever enter that room again. It is quite stunningly real. There are other possibilities for delivery and interaction, and that in particular has to do with Internet of Things and sensor communication. Here an example of a robot, a robotic arm that you can work with using different protocols. On the right, an example of one sensor and armband that we've worked with, and different types of protocols, how you interact with that software and pull the data out. That armband here not only has a motion sensor, but it also has a muscle pad, so it can pick up whether you're doing funny movements with your hands. And it can be used to create illusions like this. So that's something that Will introduced a while back. As a fun demonstrator of what you can actually do with similar type of hardware. And I think that's a nice demonstration of the things that are possible. Yeah, so what is augmented reality? A short recap here in the middle. Augmented reality refers to enhancing human perception with additional artificially generated sensory input to create a new experience. And of course, it creates that by the mix of offers, combining digital offers with natural offers, and of course, and that's something we should not forget, it is not restricted to vision. There are, in fact, quite a range of other senses that people hack into that we can serve. Yeah, experience is a word that I've used now repeatedly that has an idea history as well. experience comes maybe from Nozick's derived values of living. We have identity, which is about who we are. We have legacy, which is about what we do. And we have experience, which is about what we feel, what we experience. And if we recognize that, then maybe we also want to follow the economic ages as differentiated by Pine and Gilmore. We may have run through over the ages different economical spheres, from an economy of commodities to an economy of goods to an economy of service to an economy of experience. And the best example how to differentiate those is probably coffee. So if you look down there, we see in the commodity age that the economy is largely agrarian, where we extract natural resources that are fungible, that can be stored in a bulk, that are sold in a market by a trader and have characteristics that are facts almost. Whereas in a goods economy, which is the industrial age, we make products that are tangible, that are standardized, that are inventorized, that are manufactured. The buyer is called a user, and the factors of demand are not characteristics but features. We can see that reflected in the price. Coffee beans are cheap, and even if they are fair trade, they're still very cheap. Then assembled goods, ground coffee, Italian roast, whatever flavor, is a little bit more expensive. The service economy then, and as you clearly can see from the existence of all those at the same time, they're not mutually exclusive, they're just stacking up on each other. The service economy looks at delivering services that are rather intangible. They're customized, they're delivered on demand from a provider to a client, and it gives certain benefits like being awake. That then differentiated from the experience economy, where it's an economy in which we have stages, we create memorable experiences that are personal, that are revealed over a duration, that involve stagers and stage managers, and involves guests rather than users. Yeah, and the factor of demand here is then sensation. So this, I think, is a quite nice distinction between different sorts of economies that we may or may not have run through over the decades and centuries. But that is certainly very characteristic of through the same sort of development. We go from kind of object-centric, product-focused things like here. That's from some work I did at the Open University with the undergraduate prospectus in making volcanoes appear and explode. Then to some work from Dakri here, illustrating how to set up a certain pump system. From object-centric to activity-centric to performance-centric, focusing on what you want to achieve with that rather than what it is. So I think technologically, the augmented reality has run through a similar development. As I said, they coexist, but of course complement each other. So we can build a value-add chain, converting commodities to goods, providing the services around them, staging experiences around them, and ultimately create transformations. Following the proposal of Pine and Gilmore again, the age of experience, there are 4 different quadrants of experiences stacking up in between the level of immersion and absorption and passive versus active participation. And when we look through those 4 quadrants, then we can see a top right educational experiences that are more absorptive, more active in participation. Different than entertainment, which is also very absorptive, but rather passive in participation, and then aesthetic and escapist experiences on the bottom that are more immersive and more active or passive, depending on which one it is. So as an example, for the escapist one, going down into the Grand Canyon is an escapist experience, whereas going into aesthetic experience is probably something more like a museum visit. In total, certainly experience and storytelling go hand in hand. With storytelling, we create and help people have the experience we want them to have. And with experience, we make sense of the world as we have it. So it's something that has to go hand in hand to work. It works from both directions. There are other conceptualizations about what augmented reality is that you will find out there. Quite often, we have to fight a little bit against the difference between virtual reality and augmented reality. In my lab, for example, we focus only on augmented reality. We're not really interested in virtual reality. And even years after, it sometimes is quite tricky to explain to people that we're not doing it. As virtual reality is, I would say, a couch potato medium, but following some brighter people than me, replaces reality and requires realistic images, whereas in augmented reality we can do with minimal rendering and only parts. And we don't need as sophisticated displays at the same time because it's not fully immersive. And at the same time, virtual reality can do with very simple tracking as you are in a virtual world, and the lag between what our eyes perceive and what you see in the real world is not that it's not that important. Whereas in augmented reality it does. When you have an augmented reality application that doesn't properly track objects or rooms, then you can just see how things lag behind. Or if you turn your head, then it just loses its ability and jumps and jerks. Quite popular amongst scholars is a work from 1997 from Ron Azuma and a colleague about what augmented reality is. And he says it three things. It combines the real and the virtual. It's interactive in real time. And it's registered in 3D. So you know where things are in the real world in a fixed place. Funnily, that definition is a little bit broken and way too technical, in my opinion. A little bit broken because it just repeats the combines real that it tries to define in its definition. Rikimoto and Nagao defined it as different types of interfaces. So if we look at the four essential types they distinguish, we have the GUI, virtual reality, ubiquitous computing, and augmented interaction. And they are all about where the computer is and where the real world is. So if we look at the graphical user interface, this here is one of the first graphical user interfaces, the Xerox Star, after which then Apple's operating system was modeled, after which then Windows was modeled. There is a gap clearly between the user interface, the computer, and the real world that needs to be bridged, and quite often that is where usability or user experience problems come from. Virtual reality, we all know from the games industry, or from some of you may have seen Second Life or have heard of Active Worlds, the predecessor before. These were huge, multi-player is probably the wrong word, multi-user online environments without a real purpose, a little bit like Minecraft, maybe not as successful. And were also at the time a lot of universities starting to have a virtual presence on Second Life and do their education in virtual reality. It somehow never lifted off really, but there are still some very interesting applications in that field. So virtual reality is where you clearly are in a computer-generated world, in an alternative world, not in the real world. And anything that you do in interaction with the real world and is mediated by that virtual world creates quite funny applications and with cages where people need to be secured so they don't tumble over. Ubiquitous computing then is slightly different. It is about a lot of intelligent devices. Here's an example of the smart home, where you would possibly have a lighting system that reacts, a heating system that reacts to your usage behavior and patterns. You might have some Wi-Fi system that allows you to do a home cinema quite easily from your phone and whatever else. There are technologies that in that sector we work with AR as well, in particular with beacons, for example, to use landmark points that are marked with such a beacon, an electronic emitter that tells mobile devices, I'm here and there is something you can do with me. And that can be quite a useful way to trigger experiences. As you can imagine, discovery of where you can have an augmented reality experience is still a bit of a thing. There are platforms that we work with in research here as well, like that's an ESP32, that's a little Arduino environment, it's about that size, which you can use to hook up additional sensors such as temperature or motion capture or whatever you would like to do, and communicate with an augmented reality device. And then in their distinction, you have augmented interaction where the computer becomes the gateway device, which does not mean that it necessarily doesn't have then any physical correlates and you're just touching thin air. That's from a Magic Leap patent some while back where they used totems, kind of 3D printed inanimate non-electronic objects as a projection surface so that you can actually touch something and still have that haptic experience even if it's just a stone's lead. Yeah. So different types. And if we look at the more modern forms that we've seen amongst you, then we certainly have kind of this from reality to virtuality continuum, which is also then something that you quite often find in the literature. So this one here is another widely cited paper from 1994, Milgram's reality virtuality continuum. From the real environment to the virtual environment, he would call anything in here mixed reality. That has then the extreme positions of virtual reality, which is excluded from mixed reality, and the real environment without anything digital, and the mixed forms of augmented reality or augmented virtuality in between. So augmented virtuality is, I think, probably nothing that you guys are yet familiar with. So here's an example. Augmented virtuality is where you have something like a virtual world, but then you have a video picture projection inside of it. And if you have seen, for example, our Atlas Artists exhibition last year, there was also a virtual reality piece where you could cut into the fabric of reality a hole, which would flip open and you would have a video feed of the real world coming into the virtual world. So that's augmented virtuality. Yeah. A very recent paper, which I hope will become a bit of a standard literature, from Max Speicher and Michael Neveling and a colleague. They did a huge study, what notions for mixed reality you find out there, and then tried to distinguish also with literature what are the dimensions that we can find. And we already talked about this in the lecture 2 weeks ago briefly. There is the use of the continuum where mixed reality is everything in between reality and virtual reality. There is the synonym use with AR There's the use of mixed realities only, where you collaborate with others, where you have a combination of that, where you have the alignment with the environment, the spatial alignment, and where you have strong AR. And then they all differ amongst those dimensions, which are the number of environments. Do you have one or many? The number of users, do you have one or many? And the level of immersion, the level of virtuality, the interaction styles, whether you're just reactive, implicitly interacting to something that is catered to you, or whether you actively manipulate some of the digital elements. And then, of course, the input-outputs, which are for the moment all the same, any inputs and outputs, but that may actually, with future words and future notions, change, that there are specific forms of a diminished reality, distinct reality, imagined reality, where one would say that is only to do with a specific form of input or a specific form of output. Yeah, there are other forms around, other notions as well. The visor continuum, for example, is about the types of computing we use, from one person, many computers, to one computer, many people. So kind of from the ubiquitous computing perspective, with multiple phones and whatever not in your pocket and in your environment, to the mainframe situation where you have one server on which many people are working, somewhere in between the PC. And if we combine that with the Milgram continuum, from reality to virtuality, then we also get an interesting notion here with different forms of augmented reality. So if you look at the kind of one computer, many people situation, the monolithic computing on the top, and the virtual environment, then you have cave installations. I'm sure you've seen or even tried out yourself a cave installation. You go into a cave, there's projection all around you that possibly also even reacts to what you do, so that you have a quite immersive feeling of a projected virtual reality around you. And then in other forms, you have handheld AR, outdoor collaborative AR, and so on and so forth. Yeah, an interesting distinction again here, and that is focusing more on cognition, is the cognitive load model from Wang and Dunstan, where they look at different output mechanisms, a continuum from non-immersive to immersive, and an input mechanisms continuum that is from non-intuitive to intuitive, so kind of from real-world manipulation to supplemented manipulation. And you can predict from there and also some sort of cognitive load level. If you use awkward interaction mechanisms with awkward visualizations, it's probably more difficult than if you use something that uses direct mapping and natural interaction in an environment that you kind of know already anyways. So they proposed, based on that, to look at those 4 categories, do a ranking of the application you have in mind, and then you can kind of predict the cognitive load that you can expect on the side of the user. Yeah. Another notion that we came up with in the context of our work for the European Space Agency is a bit more technical and a bit more about the rendering in itself. So when we go through the production chain from authoring to then publishing to the delivery on the client side, we typically would see the interaction data itself, the activity data itself. So presentation-related elements with trigger conditions. What happens if somebody air taps something? What happens if somebody has a voice command? And the interactions that are then unfolding in a device that roughly follows an execution like this. So you have a trigger component that matches triggers coming from sensors with the activity, and renders then the augmentations to present them back to the user as stimuli, who then reacts again. Yeah. Other notions that you certainly have come across, telepresence, although all of these can be quite fluent definitions that have something to do with AR as well. GPS, geographic information system, and then some fabrication, 3D printing and so on. And then some more descriptive ideas such as cyberspace, or the metaverse, or virtuality, are not the same as augmented reality, but certainly have something to do with it. And we can quite easily distinguish based on whether they provide a virtual world, how real it is, or whether it is an image of the real world out there, whether they provide and rely on accurate registration or not, and how interactive they are. Yeah, so that is a short overview on what augmented reality is and what important definitions you find out there. All of the papers that I've cited are kind of standard literature that you would see, you would read. That's where all the textbooks typically have gotten their ideas from. And that should give you a good overview of what augmented reality is and what augmented reality is not.